Question 3 of the KCSE 2024 paper 1, we have a straight line L1 whose equation is y is equals to 2 minus a third x meets the x-axis at Q, and then we are told that another line which is a straight line L2 is perpendicular to L1 at Q. Find the equation of L2 in the form y is equals to mx plus c, where m and c are constants. So this is a very wonderful question, but it is a question that a person is likely to make a question very easily. Therefore, it's very important that as you do this question, you have all your focus and all your concentration onto this question, because it's a question that demands so. So let's get into it together, and actually if you wish you can actually get to attempt it on your own, and then you come back here and see whether you really got it right. But then if you're ready, we can just work on it together. So we are told that a straight line L1, so that's where we are going to kick off from, that is L1. So each and every time that you are solving a question, we usually start with all the information that we have, because that is which gives us what we are not given, and then from there we are able to solve the question. So you are told that L1, its equation is y is equals to 2 minus a third x. And then we go ahead, we are told that it meets the y-axis at point Q. Therefore we can see that we have been introduced to another point, that is Q. But what are we told about Q? We are told that this point Q, it is at the y-axis. Therefore it's important that we note that down. Y-axis, it is at the y-axis. But what do we know about y-axis? At y-axis, x is always equal to 0. Therefore the value of x is 0 at y-axis. Therefore we can work out the value of y given this equation, that is L1. We have y is equals to 2 minus a third x. And we have 2 there, and we have minus a third. We know that at this axis, that is at y-axis, x is equals to 0. Therefore we are going to replace this one by 0. Therefore we get is equals to 2 minus a third multiplied by 0, that is a 0. Therefore 2 minus 0, that one gives us a 2. Therefore the value of y for this case is 2 there. Therefore if we could write that is point Q, which was in terms of xy, it is point 0, because you know that at y-axis x is equals to 0, and then we have y is equals to 2. Therefore that point is 0, 2. You can see how interesting it is, because just from one equation we have been able to find the equation of this other point, that is point Q. Let's go ahead with the question and see what we are told. So we have L1 is equals to y is equals to 2 minus a third x. Let's see whether this equation can help us to find another thing. And definitely it's possible to get another value out of this, and that is the gradient of this line. We can be able to find it. But the way that we can be able to find it is if we can rearrange this one in terms of y is equals to mx plus c, so that we are able to find the value of m. If we rearrange this one into its correct order, we get minus y is equals to a third x plus 2. And definitely the gradient for this one, we can call it gradient 1 is equals to negative a third. Negative a third. So that is the gradient for that line. Let's go ahead and see what this question tells us. We are told that another straight line L2 is perpendicular to L1. Wow, this is quite amazing, because we are being introduced to another line, that is L2. So L2 is perpendicular to this line over here. How do we know about perpendicular lines? How do we know about their gradients? To get the gradient of this one, L2, definitely what we usually do is that we usually pick the gradient of that other line into which it is perpendicular to, and then we reciprocate it. This one was negative a third. If we reciprocate this one, we are going to get negative 3. and then we change the sign of that. If we change the sign of -3, we are going to get a +3. Therefore, the gradient of this line L2 is a 3. So it has actually helped us to get the gradient of this line L2. We continue with the question. We are told find the equation of L2 in the form of y is equals to mx plus c. So we are supposed to find the equation of L2. And do we have the points? Yeah, we have one point, which is this one, Q. Why? Because we were told that this line meets the y-axis at point Q. That is this straight line over here. So therefore, we are going to use this point Q, which is meeting with the second line. That is point 0, 2. And then we write that we don't know the other point, which is xy. But now we know the gradient. The gradient of this line is 3. With this, we can be able to find the equation of this line L2. Why? Because we know that gradient is gotten by finding the change of y divided by changing x. Therefore, we put that into writing. We have y minus 2 divided by x minus 0 is equals to 3. Therefore, y minus 2, we can just do cross multiplication here. This is equivalent to 3 over 1. Y minus 2 multiplied by 1 is y minus 2. On the other side, we have 3 multiplied by x minus 0. We know that x minus 0 is equals to x. Therefore, we have x multiplied by 3, that is 3x. We move on. Wow, this is actually a complete equation, but if you leave it at that point, you are likely to miss the answer mark. Why? Because this is not the format that you are required to give. Because the question is very clear. It tells us find the equation of L2 in the form y is equals to mx plus c. Therefore, we have to put it into its standard form as given. Therefore, we are going to take this -2 to the right side to remain with y on the left side is equals to 3x plus 2. And this is in the form of y is equals to mx plus c. And actually, that was the required solution for that.
Visit our website now, KCSEMathematics.co.ke, to ignite your passion and excellence in mathematics.